Alright, so we're going to start off our next unit, Unit H, on radicals, beginning with Objective 51, which is talking about simplifying radicals. So before we begin, I just want to start off with a little bit of review. Let's start off with 6 times 6. When we see this, we know that we have 6 times itself 2 times. We can rewrite this as 6 squared. We can evaluate 6 squared, and we get 6 times 6 is 36. Today I want to talk about radicals. I want to talk about roots. So a radical looks like this. This one in particular is the square root. Let's talk about what is the square root of 36. So what this means here, we have the square root of 36. This means what number times itself equals 36. So anytime we have a square root and a number underneath, we're asking what number times itself gives us that number underneath the square root. So I find it helpful to write out all of the perfect squares that we know. So we're going to write out 1 squared, 2 squared, 3 squared, and so on. So 1 squared is 1 times itself is 1. 2 squared is 2 times 2 is 4. 3 squared is 3 times 3 is 9. 4 squared, 4 times 4 is 16. 5 squared, 5 times 5, 25. 6 squared, 6 times 6 is 36. 7 squared, 7 times 7 is 49. 8 squared, 8 times 8 is 64. 9 squared, 9 times 9 is 81. And 10 squared, 10 times 10 is 100. So I think it's the most helpful if you memorize these, but you can always write these on the top of your in-class practice and on top of your quizzes just to help you and for reference. But I would recommend memorizing each of these. These are very helpful to know. So looking back at this, we have the square root of 36. What number times itself equals 36? So we have the square root of 36. Do one of our perfect squares, do we have something times itself equals 36? Well, if we look through these, we find that 6 squared, 6 times itself, is 36. So what number times itself equals 36? 6. I can ask you, what is the square root of 81? So what number times itself equals 81? That would be 9. Likewise, what number times itself is 49? That number is 7. So the square root of 36 is 6, the square root of 81 is 9, and the square root of 49 is 7. Let's evaluate a few. So here we have the square root of 4. This is asking what number times itself gives us 4. That would be 2. The square root of 9. What number times itself gives us 9? That would be 3. What number times itself gives us 16? That would be 4. What number times itself gives us 36? We did this one. That would be 6. And what number times itself gives us 81? That would be 9. So fortunately, all of these worked out nicely where we take the square root of each of these numbers and they give us these nice round numbers, 2, 3, 4, 6, 9, just nice even numbers. But that's not always the case. Go ahead and flip the page. We're going to discover how can we evaluate these square roots when they are not perfect squares. So on the following page, we have 2 different methods for simplifying these radicals, these roots. The first method is what I like to call the jailbreak method. This is my favorite method to simplify radicals. So the jailbreak method, let's take a look at this example here. We have the square root of 80. Now I know our perfect squares. We have 81 as a perfect square. We can say the square root of 81 is 9. We know that the square root of 64 is 8 times 8. So the square root of 64 must be 8. So it's got to be between 8 and 9. But it's not exactly 64 and it's not exactly 81. So it's not going to be exactly 8 or 9. It's going to be something in between. So we have to use the jailbreak method. the jailbreak method, step 1 is to break down the number inside the square root So break down the number inside the square root until no more numbers can be broken down. So what do I mean by that? Let's take a look at this example. Let's break down 80 until we can't break it down anymore. So 80, we can break that down into 40 and 2. 40 times 2 is 80. You could have chosen 10 and 8. You could choose 16 and 5. Any factors of 80, you can break it down. And we'll continue breaking it down until we can't anymore. Can we break down 40 anymore? We sure can. We can break down 40 into 10 and 4. Can we break down 2 anymore? No, we can't. Just 2 and 1, but that doesn't break it down. So what about 10? How can we break that down? We have 5 times 2. And what about 4? Can we break that down? We can break that down into 2 and 2. So now we look at the bottom of our tree here, and we've got all of these different factors. So we look at the ends of each of our branches. So we still have a square root. We still have the square root of 80, which is 2 times 2 times 2 times 2 times 5. So we still have square root of 80. If you were to plug this in your calculator, you'd find that this is still equal to 80. So 2 times 2 times 2 times 2 times 5. All right, so we've broken it down. That's step 1. Step 2, and I'm going to use a different color for this. Step 2 is you need a partner to escape jail. So partners become 1 outside the square root. And I'll explain what I mean by that. Alright, so looking at this square root here, we've got 2 times 2 times 2 times 2 times 5. We're going to look at all of the partners. So looking here, we've got partners are two factors that are the same. So 2 times 2, they can be partners. They're going to escape together. So on the outside now we have 1. They become 1, 2 outside. What's left over on the inside? We have 2 times 2 times 5. All right. Do we see any other partners inside? Well, there's another pair of 2's. We can take those and pull those out. So we have on the outside, we have 2 times the 2 that we just pulled out. They become 1. So we have 2 times another 2. And then what's left over inside? Just 5. Well, on the outside, we have 2 times 2. That's just 4. So our final solution is 4 root 5, or 4 times the square root of 5. Let's talk about the other method. So the other method just has one step. We're going to rewrite the number inside the square root as a product of one of the perfect squares and another number. All right, so let's look at this example again. We have the square root of 80. We need perfect squares, so let's write out some of our perfect squares. We've got 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and so on. We can continue on and on and on. So we want to rewrite 80 as a product of one of these and another number. Well, you're never going to use 1 because 1 always goes into any number. Any number times 1 is itself. Let's check. Can we take 80 and can we divide it by 4? Plug that into your calculator, see if you get a nice round number. We do. So when you divide 80 by 4, you get 20. So we could use 40, but let's continue. We want to choose the largest perfect square. Can we take 80 divided by 9 and get a whole number? Plug it in your calculator? No, we do not. Can you take 80 divided by 16 and get a nice whole number? Yes, you can, so we can choose that. When you do divide it, you have 80 divided by 16, that gives you 5. How about 25? Can we divide 25 into 80? We cannot. How about 36? 80 divided by 36, also not a whole number, so we can't choose that. So we're going to choose the largest perfect square that we found, which is going to be 16. 16 times 5. So we can rewrite the number inside the square root, 80. We can rewrite it as a product of a perfect square, 16, and another number, 5. So we can rewrite 80 as 16 times 5. Right? We know 16 times 5 is 80. And we can break this apart. This is getting ahead into our radical rules, and we'll talk more about this part later. But we can always break a product inside a square root into 2 roots. So we have the square root of 16 times the square root of 5. We can break that apart. Well, we know what the square root of 16 is. That's one of our perfect squares. The square root of 16 is 4. And then square root of 5, can we break that down? We cannot. And if you notice, we get the same answer, 4 root 5 and 4 root 5. So either method is fine. I prefer the jailbreak method, like I mentioned, because you don't have to know those perfect squares. You can just keep breaking it down into its prime factorization. Just break every factor down until you can't break it down anymore. So we're going to get a lot of practice on this. Go ahead and review your notes, and we'll get some practice. This is Objective 51.